Hello and welcome. My name is Bill Calero and I am the Program Manager for Microsoft Cloud PKI. You'll notice a slight name change in the session title, Simplifying Certificate Lifecycle Management with Microsoft Cloud PKI, not Managed PKI, and this is to reflect the official product name at the time of this recording. With that said, let's begin. A lot to cover here in 30 minutes, and time is against us, as they say, or me in this case, and so I must be brief when covering a few of the slides. I've got an acronym decoder card here for you. This is for your convenience. PKIs are, essentially it's a dense topic, lots of acronyms in the subject matter, and sometimes things like this could be super helpful when reviewing the material at a later date. And so let's keep rolling. First off, Microsoft Cloud PKI will be part of the Intune suite. It will also be available as a standalone offering, or what I like to refer to as a la carte, but either way, you can get it through the suite or separately individually. I'm sure you've seen this slide. It was used at Ignite when Microsoft Cloud PKI was announced or talked about during a session or two, and this is what we call the hero scenario. And for brevity and time, I'm just going to cover the highlights. PKIs are complex. No one's going to dispute this fact in reality. We've heard time and time again over the years, there's a lot of customer demand and interest for Microsoft Intune to provide a cloud-based PKI offering, and well, here we are. The value prop and mantra that's been driving us since day one, since we started down this journey, really has been to consolidate and simplify PKI, right, public key infrastructure, to reduce the cost and complexity associated with it and what customers embrace every day, okay? Basically, the ability to stand up a PKI in minutes versus weeks and months of planning, coordination, procuring, and deploying, right? Essentially, you won't need an on-prem certificate authority to issue those device certificates used for client auth, right? You won't need to deploy an Endesk server. You don't need certificate connectors, no proxies, right? Azure App Proxy or any kind of reverse proxy on-prem. You won't need to poke holes in your firewalls. None of that's required. So immediately you start seeing some of the benefit and some of the simplification that we've done here for you. So let's get into some of the features and I'll cover the architecture. At a high level, essentially for our first release, this version 1 set of features, you will be able to issue certificates for Intune managed devices, right? You'll be able to manage those issued certificates. Well, we will support the ability to deploy those certificates automatically. You'll be able to automatically revoke certificates and manually revoke certificates if the occasion arises. So certificate revocation will occur automatically when devices are retired, wiped, or deleted. And then, of course, the manual certification, that's something that an IT pro or admin has to go in and perform manually. So those are the edge cases on the manual side, but it will be available. There'll be monitoring and reporting, and of course, the scenario is really centered around certificate-based authentication, right? The supporting the current scenarios that we support today, Wi-Fi, cert-based auth, VPN, Windows Hello for Business, essentially applications that support certificate-based authentications, those should be well served with this scenario. Diving in a little deeper for version 1, okay, let's get into some specifics here. So you will have the ability to create a certification authority per Intune tenant, per your tenant. And so you can create what's called a 2-tier PKI hierarchy consisting of a root and issuing CA in the cloud, okay? And so you're restricted to a 2-tier in the cloud. And so you can create one root with multiple issuing CAs underneath that, or you can create multiple roots with corresponding issuing CAs underneath that. And really how you deploy or how you choose to deploy will be up to you. We will also support a scenario called bring your own certificate authority. This is the ability for you to anchor an issuing CA that you create in your Intune tenant in the cloud and anchor that to your private certificate authority. And of course, in that scenario, we can support N+, right? Multiple tiers in your PKI hierarchy, okay? In terms of the signing and the encryption algorithms that we will support day one, it will be RSA. We will support key sizes of 496. We will not support 1024. In terms of the hash algorithms, SHA-512, we will not support SHA-128. So keep those things in mind. Those are actually considered insecure these days, or strongly advised not using them. And so we are aligning with that train of thought. We are providing what's called a Cloud Certificate Registration Authority. This is what you would essentially know as your NDES server, right? Essentially, and that will support the SCEP protocol. We are providing this service in the cloud. Another huge benefit here. That's pretty monster. It's pretty big. And then, of course, the ability to host and support and update the certificate revocation list through CDP, certificate distribution points. That's all on us, okay? In terms of the leaf certificates, or what's called the end entity certificates, what's going on the device itself, it will be a SCEP-based certificate, and it will be done through the SCEP protocol. And we will continue to support, day one, the current set of platforms that we support today with that SCEP certificate profile that you may or may not be familiar with, depending if you use it today or not. And then I think I covered cert lifecycle, issuing, renewing, revoking, both manual and automatic in the previous slide, reporting and dashboarding capabilities, and of course, having the capacity to audit any kind of action performed against the CA, creates, stopping, pausing, deleting. All those actions are audited and logged in the Intune service. We will provide a set of new permissions that are related to the Cloud PKI. The ability to create a CA, delete a CA, modify a CA, the ability to create what's called a certificate manager, where that certificate manager can only essentially revoke certificates, and that's all that they can do. And of course, scope tags, where scope tags are essentially used to control visibility. So if there are multiple PKIs in your Intune tenant and you have different administrators over different lines of business, and you want visibility and control over those, scope tags is where you go to take care of that kind of thing. Let's get into the architecture and flow of things. This discussion could get dense, but like I said, I must be slightly brief, but let's go into it. Number one, you've got your Intune administrator. This could be a global admin, this could be the Intune administrator, or it can be a CA administrator that you create with those RBAC permissions. Okay, it could be a custom role that you create in Intune. That administrator will create the CA, right? They'll create a root CA and an issuing CA, or they will create an issuing CA that's anchored to your on-premise CA infrastructure. That's the BYOCA scenario. We are providing the SCEP infrastructure. There's nothing for the IT pro to do in that case. And then, of course, either the same CA administrator or an MDM administrator, or again, someone with the privileges to create the certificate profiles, the trusted certificate profile, the SCEP profile, Wi-Fi, VPN profile. Again, someone creates those, and then they assign them or deliver them, target them to their appropriate devices or users that they wish to have access. In this case, I'm going to just keep the conversation to the SCEP profile. Once that device gets that SCEP profile, it's going to do a device check-in. That happens normally on every device check-in. And so that device will request a certificate. And first, it will create what's called a CSR, a certificate signing request. That certificate signing request essentially mints what's called a private key on the device. And this is a reason why some folks prefer using SCEP profiles versus PFX profiles, because that private key will never leave the device. And from a security perspective, that does have advantages. Anyhow, that CSR gets created and sent up to the SCEP service in the cloud. Using the SCEP protocol, we generate what's called a SCEP challenge. That challenge is then compared against what's in that certificate signing request. And if the values do not align to what we expect, essentially the values that you create in that SCEP profile do not align to what we expect from either Azure Active Directory or within Intune, depending on how you created that SCEP profile, we will reject that certificate request. If they do align, they do match up, then we say, hey, you're good to go. And we essentially, the SCEP service, otherwise known as a certificate registration authority, will request the certificate to get signed by the issuing CA in the cloud. Issuing CA signs it, and then the certificate registration authority or the SCEP service delivers it to the device. And there you have it. So again, pretty dense stuff, but very cool stuff. Big takeaway here, essentially, this service that we're providing in the cloud replaces your on-prem CA for issuing those device certificates. You don't need an NDIS server, you don't need the certificate connector, and you don't need to configure any kind of proxy servers or touch firewalls for this. So let's go into the console experience. It is demo time. Here we have the Intune admin console. Okay, you're familiar with this, I'm assuming. And so the Cloud PKI management service will live under tenant administration. And so at the moment, it's called Managed PKI, but again, remember, the name change just occurred at the time of this recording. It will be called Cloud PKI. Nonetheless, once you click into Cloud PKI, you're going to see your new world here, right? This is where you see your issuing CAs, your root CAs. This is where you come to create CAs and manage CAs. You're seeing, of course, some CAs in the list. And so this is because I've done a number of demos with this test tenant of mine. And so, but I'm going to walk you through a full end-to-end experience. So we're going to start with the root CA. Here we go. So I'm going to create a new root CA. This is the object name, not the actual subject name of the CA. And I'm going to call it TTO for tech takeoff. And we're going to call it root CA. And I'm going to hit next. And then we're going to select the CA type. In this case, it's going to be a root. We're going to select the validity period to be 10 years. A required field is the common name, or known as the subject attributes, but common name in the subject attribute is required. And so again, I'm just going to call it tech takeoff, root CA. You can obviously give it a different name based on your needs. The other fields are all RFC supported fields, but they are optional, not required when you're creating a CA. And then down below, you've got something called the encryption. This is the hashing algorithm and the algorithm, the signing and encryption algorithm. And so these will be in pairs. So at the moment, we support, as I said, 496 RSA and SHA-512. We support the lower items, but not 1024 or 128. I'm going to pick the high-end value. Note that when you're creating your SCEP profiles, you're going to be able to create up to 496 and use SHA-512 hashing. Okay, hit next. And then ensure that everything looks right to you, all the descriptions, the names, everything looks right, because once you hit this create button on the far right over here, you won't be able to edit these items here, okay? And so just be sure, review before you go. So I'm going to hit create, and you're going to see this notification up here on the top right corner, and it's basically saying, hey, we're creating your certificate authority. I'm just going to give that a few minutes, and voila, it is created, okay? So then I'm going to come over here to the console, and I'm going to hit refresh and cross my fingers and hope that I see it. There it is, TTO root CA right at the bottom. Next, what I'm going to do, I'm going to create the issuing CA. Okay, now you have to create an issuing CA because the issuing CA is responsible for essentially signing those certificates per request from the SCEP profile. And on the issuing CA, this is where we create the certificate registration authority known as the SCEP service and align it to the issuing CA. Okay, so TTO issuing CA, hit next. I'm going to select the type here will be issuing, and I'm going to cross my fingers and hope that it comes up in the list. And I'm going to scroll down to the bottom, and there it is, TTO root CA. So I'm going to anchor this issuing CA to the trusted root in the cloud that I created in the previous step. Next, I'm going to select the validity period, and essentially the max that you can do is half-life of the root. Again, these are just best practices. Of course, you can go lower than that. And then the common name, so TTO issuing. It doesn't have to be the same as the object name. It can be different. Issuing CA. And then I'm going to skip the other items here for brevity. And we lock in the encryption keys based on what's selected for the root. Again, you can select lower base keys when you create those SCEP profiles. Hit next. Review my settings. Make sure everything looks good. And then hit the create button. Cross my fingers, I get the notification on the top, and hey, beautiful, this thing's rocking. So I hit refresh, and tick tock. All right, here we go. So you've got your issuing CA that we just created, and let's jump into that item here, okay? And so there are a few things that I just want to highlight. Number one is the curl distribution point, right? This is, again, something we host. This is your certificate revocation list. When certs get revoked, this list gets updated, and it's actually going to be updated every 7 days and refreshed. And so the SCEP URI, this is the SCEP service URI that's basically aligned to this issuing CA. This download button here reflects the public keys for this issuing CA. There's a download button on the root CA. Again, for brevity, I'm not showing you the download button on the root CA, but you'll need to download those certificates to create your trusted cert profiles. Anyhow, you will need to copy this SCEP URI, and this SCEP URI is essentially what you're going to use in the SCEP profile. And I've already have one set up for you so that you can see where you place that. So this is a SCEP profile. I'm sure many of you are already familiar with this because this is what you use today with your NDES deployments to issue those certificates using your on-prem infrastructure. So essentially, you just plug in that SCEP URI in this placeholder here. So that's the property. And if you've done an NDES deployment in the past, you're going to be like, wow, this is super easy. And so you are welcome. All right, so that was the demo. I hope you enjoyed it. It was pretty thrilling for me. And let's keep the ball rolling here. So let's get into what I like to call a storyboard. It really maps out where we are today, what you will have when we GA, when we go general availability, meaning version 1, and then what you will have tomorrow, what's coming next, right? So in my opinion, the future is quite bright with Cloud PKI. So this is where you are today, right? You've got the Intune certificate connector, or you've got what's called a third-party SCEP API, just depending on what you're using today to deliver client auth certificates to your set of managed devices. The blue certificates in this layout here represent those client auth certificates, right? And so you can get them, as I said, from a third-party Cloud PKI that you're paying for, or you can get them from your on-premise Active Directory certificate server or some other Active Directory certificate server, or your private CA, I would just call it that. And essentially, we rely on these sources to get you these device certificates to the managed devices, okay? And that's where the certificate connector comes into play. You've got to deploy an NDES server. You've got to configure a proxy server. You got to do a lot of heavy lifting here, right? And then, of course, that private CA or that ADCS environment is still issuing different certificates for different purposes. In particular, in this scenario down below here, it's essentially that SSL certificate, right? And so whenever you're doing any kind of secure connection to any kind of service, you need an SSL certificate. And we're not doing that, right? We never did that. And so in this case, we're not doing it for the certificate connector that you see here, right? So this is complex and costly, right? I'm sure, you're down this road, you understand. And so let's talk about what we're going to bring to the table with version 1. Okay, this is our first release. So you will begin to see that we essentially remove a lot of the complexity. You can obviously still continue to use your third-party CA, but again, that's a cost as well. But if you currently use the connector and an NDES server and a proxy server, that goes away. That's a big deal, okay? And those who experience that today, they know that that's a big deal. Now, of course, the current set of certificates that we never issued or never worked with, like the TLS certificate, you still continue to rely on your private CA or your ADCS server, Active Directory certificate server, for that certificate, okay? And you need that certificate. So essentially, with version 1, we're going to simplify, reduce the complexity, reduce the cost, but you continue to rely on other PKIs, right? That's the way it is, version 1. We can't essentially, build everything day one. We got to crawl, walk, and run to get to where we want to go. So let's talk about what's next. Here we have what's possible. And I'm not promising anything right now. What I'm saying is that the future is bright, okay? And so what you're seeing here is you've got Intune Cloud with the Cloud PKI service in there, and we're issuing the device certificates, the blue certificates, but we're also, again, pretty aggressively working on delivering other types of certificates. SSL certificates in particular is the forerunner, right? So you really need that TLS SSL certificate to complete that full end-to-end connection when a device attempts to connect to any one of these relying parties, on-prem, Wi-Fi access points, your VPN servers, your applications, that kind of stuff. And so this is something that we intend to, work on. And so the goal is really the lift and shift, right? Moving that certificate workload to the cloud, making it simple, comprehensive, and complete. So just want to summarize the benefits here real quick for you. Immediately, right, just on version 1, no NDES server to deploy. There's no servers to procure, no change control. You don't deal with that, okay? No reverse proxies to configure, whether they were on-prem or the Azure App Proxy. You don't have to deal with that. No firewall holes to poke. You are going to reduce the workload on your on-premise CA and the associated operations with that, right? The database size, the maintenance associated with it, that goes away. And of course, the ability to stand up this infrastructure in the cloud in less than 5 minutes, right, is impressive. Okay, it's pretty good. Let's get into the deployment approaches because this is super relevant and this is where there's a lot of meat and potato here, and I hope I don't lose folks. But those folks versed in PKI should be able to follow along very nicely. Essentially, the two deployment scenarios, what's called the Cloud PKI root CA or bring your own certificate authority. But before we do that, I need to talk about a basic understanding. And again, just want to cover as much ground and as much of the fundamentals as possible. There are two certificates that are in play, two main certificates or end entity certificates that are in play for cert-based authentication. Essentially, you've got your SSL TLS certificate. And so again, anytime you're doing any kind of secure connection over the net or on the wire, hopefully it's over SSL. If it's not, you're in trouble. The other thing is the client certificate, right? That certificate that's doing client auth, okay? Remember, this is a cert-based authentication scenario, so you need these two certificates. And so currently today, you rely on your ADCS environment or a third party to issue that TLS SSL certificate, and you need the client auth certificate. So those two things are currently coming from another PKI. Now, we're the middleman in that scenario today, and so with version 1, the client auth certificate, we take that on, okay? That responsibility becomes our responsibility in Intune. And so that starts to alleviate things, right? And starts to make things much better. Let's talk about something called chain of trust, another very fundamental concept that must be well understood, especially as you begin to deploy and adopt. So in the previous slide, I showed what's called the end entity certs that are in play, the SSL certificate, the device client auth certificate. And these slides show these cert certificates too, but the emphasis here, what I want to convey is that chain of trust, right? Something called the CA certs or the public keys for the certificate authorities responsible for the SSL certificate, whatever issues that SSL certificate, and whatever issues the client auth certificates. And so a nuance or an important call I want to make here, and it's not very clear in this slide, right? But I'm going to cover it later, is it's related to the Intune root CA in the cloud versus the bring your own certificate authority, right? Where the root is on premise and it's already present on the relying party, right? These endpoints, okay? So let me cover a few points. You've got your Intune managed device, and you must have the trust keys, the public keys, for the Intune root CA that's in the cloud, if that's the way you decide to deploy, where the root CA is in the cloud. If the root CA is on-prem, then you still need to deploy the public keys of that root CA from on-prem to the device, okay, to establish that chain of trust. Now, for the SSL certificate, whatever issued that certificate, maybe it's not the same CA, maybe it's another CA, you need to deliver the trust keys for that certificate to the device as well. And the delivery method that's used today, okay, would be the Intune Trusted Certificate profile. Those folks who deployed it, this is a very simple profile to create and configure. Essentially, you just export those keys and you upload them to the Trusted Cert profile, and you just deliver them. You just target them to the device. You don't need any additional infrastructure to get those on the device. Very easy. The relying parties, they must have the trusted root or the public keys, as I said before, to either the Intune Cloud PKI, the root, if you deployed through that methodology, or if you deployed the bring your own CA, then essentially that root is high chance probability it's going to already be on that relying party. And so just remember that whatever TLS SSL certificate is used and whatever CA issued that certificate, that relying party needs those root keys on the server. Okay. Now the deployment method here is not Intune. It's if that relying party service is in your Active Directory domain, then you're probably going to use a group policy object to get those public keys on that server. If they're not in Active Directory, then you probably use a different method to get them on. But essentially, Intune is not the delivery method to get those public keys on that server. Okay, big point. Okay, so now let's get into what's called the root CA deployment. So in the root CA deployment, very quickly, you got the root CA in the cloud, and so you need to deliver what's called the bag of certs or the trust chain to your device. Okay, you also need the bag of certs for the SSL certificate, the TLS SSL certificate that your on-premise root CA has issued, and so you need to deliver both of those. And again, very straightforward. Intune trusted cert profile, no problem. However, because you decided to go with a root CA in the cloud, you need to get the root CA keys onto your on-prem servers. And again, this would be an out-of-band delivery, either through group policy if those relying parties are in your domain, or through some other method. And then, of course, you've got to configure those relying parties to trust that the root CA in the cloud. NPS works well. We've tested this a number of times. And so, yeah, that's your root CA deployment. Last but not least is the bring your own CA deployment. Okay, and in this case here, you've got your root CA is in on-prem, and so you're going to deliver the bag of certificates of that root CA on-prem to your managed device. Again, the Intune Trusted Cert profile does the trick there, and again, those trust keys are already present on these relying parties. Nothing to do on that front, and you get your trust established on both ends with the SSL cert and the client auth certificate. Well, that wraps it up, everybody. I hope you enjoyed the discussion. I hope there were a lot of takeaways, a lot of dense material to cover here. And I look forward to your use and deployment of Microsoft Cloud PKI. Take care.